Looks like we're live. Hello everyone and welcome to yet another Azuzin session. Let's make a little bit of announcement and maybe, just maybe officially start the stream. So let me quickly do that on my Discord tab. A red circle, live on Twitch. And what are we doing today on Twitch? Today we are coding without auto-completion in C on Linux. That's a weird title I actually decided to put on. But I would say it's a purely clickbait title for Twitch. So today we're gonna continue working on Olive.c, which is the C library for graphics, right? And today we have a couple of features to implement. Anonymous fan, hello, welcome. So, yes. Today we're gonna continue developing this thing. Right, it's a very simple graphics library in C, which renders everything into memory, pixel by pixel, without using any third-party dependencies, right? So this is kind of like the gist of the entire library, right? So the entire library works purely on CPU, or whatever thing you manage to compile it on. And yeah, it just like allows you to do graphics. You can find it in here. I should probably put some more justification for this library in the description somewhere here, so we'll see. And also maybe make examples more interesting, because right now the library is capable of doing more interesting things. That's for sure. So these examples are kind of lame. I'm not gonna lie, but I'm gonna do that off screen, of course. So let me maybe fetch some of this stuff, right? Let me take a look. We have some changes in here that I don't really care. Let me merge origin master and let me recompile everything. And to reiterate on what I've said, right? So our library is capable of doing these kind of things, right? So showing like samples like this doesn't make any sense, right? So it will be better to actually put something more impressive. Right, to be fair, this 3D example for the most part is implemented outside of the library. All of the projection is computed outside of the library, but maybe we're gonna bake that into the library as well at some point, so we'll see. So, Shanara, I hope I pronounced your nickname correctly, thank you so much for 8 months of tier 1 subscription. It's been 8 months, I almost can't believe it. Yeah, thank you so much for supporting the channel. Even though I don't get any money, I really still appreciate the intent. I still really appreciate the intent. Okay, so this library is designed to be for quick, you know, prototype graphics, right? So if you want to just quickly sort of like visually debug something, right, you would just pull out this library, and the library is designed to be able to work literally anywhere because it doesn't have any dependencies, like it renders everything into the memory. And I think one of the important things for this sort of like debug graphics is being able to render text. Right, so we want to be able to render some sort of a text, but you know, supporting like TTF fonts is kind of a pain in the ass, right? So because you have to like parse TTS fonts and stuff like that. So what I was thinking is that maybe we're gonna invent our own very simple font format that supports only ASCII, right? And it's like a monospace font that is like pixelated, like a, you know, Minecraft style font, right? And it's gonna be purely for debug purposes, but we're gonna develop that format so you can actually supply your own fonts if you want to, even including TTF fonts. Maybe we're going to implement such mechanisms that you will be able to, okay, make an atlas out of the glyphs that you care, and you would put that into our simple format, and that will work somehow to some extent. We'll see. We're gonna start very simple. So it's gonna be sort of like a bitmap font, but it's gonna be so simple you'll be able to encode that font within the C code. You know what I mean? You know what I mean? So this is actually very like a straightforward idea. So let me show you what I mean. Let's imagine that we're gonna have some sort of like a default font somewhere here. Right, so And how should I do that? So I think I'm gonna do something like char, and this is the font. And the font is going to have the ASCII amount of characters. I don't remember how many characters you have in ASCII actually, so maybe I wanna go something like ASCII. So we start with 0 and we end somewhere at 127. Okay, so let's actually say 128. Right, and then we're probably going to have some sort of a hard-coded size of the font, right? So this is going to be font height, and this is going to be font width. And maybe this should be dynamic, maybe there should be some sort of like a meta information for this kind of stuff, right? And now, let me actually define that. So let's define font height. Let's define font height to be like 5. And width is going to be also 5, right? So it's going to be 5 by 5. And how would you define a certain glyph? Right, you would say, okay, A is going to be equal to, and we're literally going to define maybe something like 0, 1, 0, 0, 0. Right, so this is the size of a single row. Right, and we're gonna repeat that 5 times. So the font is 5 by 5, right? So this is basically the font. And maybe it would make sense to actually do it like so, right? This is gonna be 1. This is gonna be 1, 1, right? And this has to be like that. Okay, so A is this, which means that maybe height has to be 4 and width has to be 3. So, and let's actually remove the rest of the stuff that is not particularly important. Right, and we're gonna basically have fonts defined like that. Right, so this is fonts that define like that, and we're gonna just render them. Right. So, yeah, that's basically the idea. That is basically the idea. I would say that it's more of a like font glyphs, right? So this is more of a font glyphs. And maybe we would have some sort of stuff like struct, and this is going to be a font. And because I want to, you know, have a support for different sizes, right? So right now these things are hard-coded, but I want to have support for several different sizes, especially custom ones. Right, so here we're gonna have width and height, and also we're going to have font glyphs, right? So this is gonna be character, font, maybe I'm gonna say glyphs, right? Like so. So it's basically gonna act like the canvas, right? So if you take a look, we have a canvas, right, which is basically the view into the pixel, and we're also going to have a font, which is the view into the glyphs, right? So this is basically the view into the glyphs. Maybe I'm going to actually move it slightly here, so the fonts are sort of grouped, everything related to fonts is grouped in a single place. And maybe all of that stuff is going to be sort of like a default font, right? So this is the font definition, this is how a font structure looks like, and this is the default font that we supply with the library, right? So this is the default font height, the default font glyphs, and then this thing probably has to be static, of course, right? This thing has to be static, and then we're also going to have something like static font default font, right? And the glyphs of that font are going to be default font glyphs. Default font glyphs. The width is going to be default font width, and this one has to be height. And there you go, right? So you have just a general font definition, right? You can adapt to that definition any font you want. And this is the data for the default font. And here's the definition of the default font that you can just use out of the box if you want to. What's interesting is that here I only defined one glyph, but I defined like all of them, which means the rest of them are going to be zeroed out, right? So I'm not gonna define all of the glyphs simultaneously, right? So I'm gonna just define a few just to test things out, and I'm gonna add more and more glyphs as I need to, right? So, of course, developing like all of the glyphs is kind of a tedious work, but if we just only define what we need, it's not as tedious of a work, and we keep filling up this font as we go. A is enough glyphs for everyone, exactly, right. So essentially, if you try to take any other glyphs out of here, like B, you would basically get an array of empty characters. Not really empty characters, but the array of zeros. Right, so that's basically how it's gonna work. It's not gonna be rendered at all. Okay, so once we have the font definitions and stuff like that, maybe we can finally define a function that renders the text. Right, so let's do Olive.c def, Olive.c text. Right, so we're gonna supply the canvas onto which we're rendering everything. Right, we're also gonna specify the left top corner of the text where it starts. Right, then I think what we want to specify, the size of the font. Right, so the font itself already has a certain size, but maybe we want to specify a multiplier. You know what I mean? Right, so maybe I want to just scale it up as I render it, and this is basically what I want to have in here. Right, so this is going to be size. And after that, we want to specify the font itself. Right, so this is going to be font. But here's an interesting thing. I usually prefix all of my definitions with Olive.c, right? So Olive.c. So, and this is something that I forgot to do, unfortunately. All right, Olive.c, to indicate that this comes from the library itself, because C doesn't really have any namespacing or anything like that, so you have to sort of emulate the namespacing yourself. Right, Olive.c font. So here is the font, and another thing that we probably want to specify is the color of the text itself. Right. So maybe I want to actually supply font first. So then after the font we have the style, right? So here's the font, then the size of the font, and then the color, right? And this entire thing is supposed to render that text onto the canvas, right? All right, so this is going to be the function, right? So I already have what to do for that, like a built-in simple monospaced font, and this is what we're developing in here. So do we have unimplemented or anything like that? No, we don't. Okay, so I think what I need to do, I need to come up with an example that just renders some text onto the screen, right? So let's maybe... oh yeah, we have tests, right? So we have a test suite, so that means I can go here and just like test all of that. So define test case, test, text, right? So this is a test text. Test. Text, and yeah, it's just a test text. To be fair, for the test I would like to actually render more, right, because the size of this thing is rather small, right? So it's going to be width 128 and 128. I'm not sure if it's going to like perfectly fit there. So, and this is size that is hard-coded for all of the examples, right? It is hard-coded for all of the examples, and it's kind of like not particularly convenient. So what I'm thinking is that in the future, this each test case should be able to specify like the size of the canvas that it want to use, right? So I think it's going to be fair, right? So that means for now I'm not going to define any test case in here. It's just I'm going to have like this thing. All right, so this is going to be test text C, right? Test text C. stdio, and I'm going to include Olive.c, right, and we're gonna define Olive.c implementation. So, and let's do the main thingy. Let's return everything. So let's like do a rather big canvas. 800 by 600. I know it's not that big by today's standard, but it's way bigger than we use in the test cases, so that's totally fine. So this is going to be pixels, width, height. There we go. Now So let's define Olive.c canvas, right? So this is Olive.c canvas, and it's Olive.c canvas pixels, width and height. There you go. So, and this thing I'm gonna just fill with certain background color, right? So this is a background color, which I'm gonna define somewhere here. Background color 0xff 2020. Right? So this is gonna be the color. And let's go and just use the text. I want to find this thing in here. Right, there you go. So this is going to be the canvas. Let's render everything at 0, 0. Right. Let's use the default font with the size 1 for now. And let's also define some sort of like a text color, right? So the text color. And I suppose for now the text color is going to be like purely white, right? So then later we can make something more interesting. Right, so something like this. So this looks like purely white. Okay, so now I think it probably makes sense to save this image to the file system, right, just to see the result. So I'm going to use the STB library for that. It's located in third party STB image write. So that's the library that we're going to be using. STB image write implementation. And if I take a look at STB write image, there should be something like, yeah, this one, write PNG. We're going to save everything in PNG. So what's going to be the file path, right? So file path const char file path output PNG. So width and height is going to be the width and height of the canvas, right? So this is going to be width, and this is going to be height. The amount of components is 4, right? It's RGB 32. So the data is the pixels. The stride is basically the size of the row, which is width, multiplied by the amount of bytes per pixels. It's basically the size of the row in bytes, right? So that's what it is, Win32T. So, and this thing returns 1 in case of success. So that means if it returns false, we couldn't save that file. So fprintf std error could not write file this because of this reason. And here I'm going to say file path str error null, right? And then I'm going to just return 1 in that specific case. There you go. So that's basically the simple program that we have. So okay. So let me try to compile this entire thing. test C, and let's see where it fails. Okay, so I renamed the constants, but I forgot to rename the places where I use them. Default. All right. So what are the other errors in here? So of course we forgot the commas in here. The commas are quite important, I would say. So default font glyphs. This one is rather interesting, right? Because here we have like arrays. But in this particular case, we have just a pointer at the beginning of all of that. So effectively, I would say that we want this kind of pointer, right? So, which looks a little bit silly, but I guess that's the safest way to actually get the correct pointer anyway. Right, so maybe later I'm gonna come up with something better, but it is what it is for now. So, and of course semicolon in here, and what else do we have in here? So we have to include a bunch of other things, specifically string for str error and error null for error null. Okay, so that worked. Let me actually run this program, test text, and that thing should have generated the thing, right? So this is the empty image, right? So this is basically the empty image. And so what's funny is that I just realized nowhere in the signature Olive.c text I actually provided the text that I'm about to render, right? But I mean, it's such a simple mistake. I mean, it's such a trivial mistake. It's super easy to fix, so I don't really care about this kind of stuff, right? So it's just a matter of just providing the text. And that's it. We fixed it. Oh my god, this is such a terrible mistake that is impossible to fix. You know what is more terrible? Forgetting semicolon. literally impossible to fix. It's not like we developed half of a century ago special programs that literally tell you that you forgot to put a semicolon in a specific place. So you should go there and actually put it there. Okay, I'm sorry. I'm just getting angry at all of these stupid memes in programming humor where people say something like, my face when I wasted entire day fixing missed semicolon. Dude, all of the languages tell you precisely the place where you forgot to put a semicolon. This is literally not a problem. It's just like, what the fuck is wrong with people? I don't know why I get angry about that so much. Because it's so fucking stupid. How forgetting semicolon in 2022 is a freaking problem when literally all of the languages tell you where you forgot to put that. Alright, anyway, so I'm sorry. Maybe people don't know how to read. Maybe that's the problem. I don't know. Most people posting and programming humor are people probably know, probably, yeah, probably. At least that explains it, right? So... I mean, I wish if all of my problems were forgetting to put semicolon. Like, I freaking wish. Anyway. Even scripting languages, even in scripting languages, it's not that big of a problem because all of them at runtime will just freaking tell you if you forgot something. Alright. Anyway, I'm sorry. So we have to provide the text. So what is the best text to provide in here? Right. So I think the best text to provide is basically the quick brown fox jumps over the lazy dog. Right, because it contains all of the letters. Right. So it essentially contains all of the letters, so that makes sense. So it doesn't contain like special characters or anything like that, but at least it will provide like enough information to render all of this. Right. Okay. So let me see. And if I open this thing, as you can see, there is nothing in there because we have not implemented that specific function. Alright. So what we're gonna do? So essentially, I suppose we can just like iterate over each individual character in the text and just render it separately. So essentially, what I'm thinking is that maybe we could have something like Olive.c char. Yeah, that's right. So essentially it's going to have like literally the same signature, except it is going to have char instead of text. Right. So I think that's a good idea. Maybe we can even make it also part of the public interface in case you want to just render a character, right? Who said you cannot do that? But I'm just thinking, is that a good idea? Maybe this. Okay, so because if you want to like render a single character, you can always just render string with a single character. So maybe it doesn't make any sense to have a separate function. Yeah, it doesn't make any sense to have a separate function. Fuck that. Alright, so let's compute the size of the string, right? So let's maybe have something like text_len, which is going to be str_len, which automatically makes us depend on the standard C library, because now we'll have to do string. Right, but maybe that's fine. Maybe that's fine for now, because it's super easy to re-implement your own str_len if somebody wants to use this library in embedded, for instance, right? So we'll see how it goes. Anyway, so let me do size ti, and I'm iterating through each and individual character of the text. That's what I'm doing. So interestingly enough, depending on I, the position at which we're rendering this entire stuff is going to be different. So I also want to like sort of denote this thing as x0 and y0 because they are initial positions, and the actual positions are going to be x0 plus I multiplied by what? Multiplied by the width of the font width. You see? Does everyone understand why? right? Because we sort of like shift into the next character. The same goes for y, and this is the actual position in which we have to render this specific glyph, right? So this is the actual position. Okay. Very cool. I'm not really sure why size is actually signed, right? So because if you make it negative, how do you even handle that? So I think it has to be size t, right? So the variable size has the type size t, of course. And here we're gonna have size t, which is size. Okay. So for now, maybe we're gonna just assume that the size is equal to 1, right? So it's equal to 1, and that means that we have to just iterate through each individual pixel of that specific glyph, right? So in a glyph, we can actually find them like this. So this is gonna be glyph, and the glyph. Ooh, this one is rather interesting. So the size of a single glyph, is a size of character multiplied by font width multiplied by font height, which means that to get the ith glyph, what you have to do effectively is text I, yeah, multiply by text I, there you go. Right, because that's the size of a single glyph, right? That's the size of a single glyph, and you just like take that glyph like that. So maybe we're gonna have some sort of I don't know, some sort of a, how to call that, macro that actually does that for us. So we'll see. So let me put it like this. So this is gonna be glyph. This is actually glyph. Interestingly enough, I think in the font definition, Olive.c font, this has to be const, right? So because once it's packed into the font, we don't really plan to modify it, right? So like there's no point in modifying it. If you want to modify it, like modify the original container, right? The original data this thing points to. So that doesn't really make much sense to actually make it modifiable. So because of that, this is going to be const, and there you go. Will Olive.c have support to capture picture from cam? No. That goes against the entire idea of the library. If you need to capture stuff from the camera, you probably don't want to use this library. You probably completely misunderstand the point of this library. This library just fills up the memory. It's just a fancy mem set. You know what is a mem set? So this thing accepts the pointer to the beginning of the memory, then the value you want to fill that memory with, and the size of the memory. And it just fills up that memory with that value. So Olive.c is basically that, but a bit fancier. Just a tiny bit fancier. It can fill up the memory with different geometrical shapes. Not just like specific values, but different geometrical shapes. So the entire library is literally just a fancy mem set. Capturing from the camera doesn't sound like a fancy mem set. That sounds like a full blown up open CV or something like that. Like, no, you misunderstand the point of this library. The point of this library is just a fancy mem set. Right, so anything else just overcomplicates the library. Okay, so let me actually open the window. And opening windows is something that our library also doesn't know how to do, so you have to do that yourself. So this is the glyph, and within the glyph, how we're going to be doing all of that. So I need to iterate through this entire thing. I wish I could iterate that with y variables, but what I'm doing, in fact, is I'm using like a dy, right? So this is a dy. from 0 to so glyph, already glyph font height, y less than that, and I think I'm gonna actually cast it to size plus y, and then for int dx equal to 0, size t, this one has to be actually dy, dx less than font width, this one also has to be dy, dx++, and there we go. So we're effectively iterating through the through all of those things, right? And here is the interesting part. So if glyph dy multiplied by font width, which the size of the row, plus dx, that means we have to put a square at that specific place, right? So we have to put a square at that specific place. So let me think how we're gonna, well, effectively, this is gonna be 1 pixel, right? So because we are working only with the size equal to 1, so that has to be 1 pixel. So let me find my special macro, Olive.c pixel, right? So this is what it's basically called. So Olive.c pixel, I provide OC, and I need to find the position. Position is actually x plus dx, right? X plus dx, y plus dy, right? Interestingly enough, I would like to actually have something like x plus dx, so that means I need to call these things slightly differently. So let's actually call this something like glyph position, glyph x and glyph y, right? So this is the beginning, so this is the initial position, this is the specific glyph, and this is the specific pixel, right? Yeah, there we go. Maybe we can even call this thing like a, this is the text position. Yeah, there you go. This is the text position. Within the text position, we calculate a specific glyph position. Within the glyph position, we calculate a specific pixel position. That actually makes sense, right? So it's a different kind of positions. Right, and pixel y is a glyph y plus dy delta y. So the reason why I want to have these things is because I want to check that they fit within the canvas, right? If, for instance, px is greater or equal than 0 and px is less than the canvas width, for instance, right? So this is quite important. 3 levels of position, yeah, that's right. 3 levels of position. Okay, so in here, less py and py less than oc height. There you go. Right. And if this is true, right, if this is true, we can just set that specific color at that specific pixel. And that should be basically it, right? So that's quite important. Of course, all of the out of bounds check has to be done outside of the loop, so we don't like spend much time on it. But it is what it is. It isn't what it is. You know, we can actually get rid of this condition quite easily. We can get rid of it quite easily. So first of all, I'm gonna just put this thing in here, right? And of course, I'm gonna just like move this stuff in here. And effectively, I can say color, but color multiplied by the glyph pixel, right? Because it's always equal to either 0 or 1. Oh fuck, this is not gonna work. So, but that actually means that we have to take the original pixel, right? So we have to take the original pixel. Though, this one is rather interesting. So I suppose we have to actually blend that stuff. Yeah, we actually have to blend that stuff. And depending on whether we have something at that specific pixel, right? Depending on whether we have something in that specific pixel, we either have to take the color or make the color semi-transparent, if you know what I mean, but it's too complicated right now. It's too complicated right now, so I don't want to spend time on that. Okay, so all right, so it's gonna be 32t. So this is going to be a pixel, right? And if nah, I don't want to get rid of that for now. Nah. For some reason, I'm really not in the mood of doing it right now, so I'm gonna just keep it like that. But one of the things I'm gonna do for sure is blending that thing. Right, so I'm gonna be blending that thing. But the question is, right, so this has to be px and py. Right. Px and py. So let me go through the thing one more time. Alright, so that should be fine. Okay, so we don't have assert, and this is probably because I have to include that assert in the first place in the original program. So this is glyphs. And that's pretty cool. Let me take a look if we... Ooh. Can you see that shit? Can you actually see that shit? I think you can. But it's located in a really weird place, isn't it? It is located in a really strange place, not gonna lie. Because the original place... Oh, it actually renders everything diagonally. Right, so, yeah, so what we have to do instead, we actually have to remove this thing. Right, so we render everything diagonally, it has to be horizontally. So that means we can actually like do vertical rendering, right? So we can actually define different directions of rendering, right? So maybe in the future when we're gonna separate like right to left rendering for like Arabic script, we can have that. Does Arabic even have a variant of like a monospaced variant? I'm not really sure if this is even applicable to Arabic. But yeah, we'll see. I feel like Hebrew looks great in monospace. It's just my general feeling. I don't know Hebrew, but it looks like something that would look great in monospace. Because it's so square and monospaced. Alrighty, so let me actually do this thing, and the thing I want to see is that one, that stuff. Right, so it's all very much, how to say that, anti-aliased. So what I want to do instead, I want to actually open all of that in the fer without any monospacing. Right, I mean anti-aliasing, so there you go. So this is a small... This is a small... Isn't that cool? Isn't that cool? I think it's pretty freaking cool. Amogus, yeah. So, this is actually so cool, I really like that. I think the time has come to do maybe B. Let's implement B. Where is my font? B. How a B would look like, chat? So I suppose it would look something like this. Right, maybe. Has to be 1, 1, 0, and maybe also 0 in here. A is capitalized and B is not. How do you do not capitalized A? I don't know. Let me think. Okay, so yeah, let's actually fix that. Let's actually fix that. I really like how I asked that and everyone is just like, that's how you do that, dummy. Right, thank you so much. Yes. Why did I ask such a stupid question? Alright, thank you so much. Okay, so... But it's up to me to render it somehow, right? I'm not sure if I'll have enough space for A. Oh man, how do you even do that? Damn, maybe we'll have to add more stuff. So we should have like a very distinct thingy, right? So there has to be very distinct thingy. But then I don't have enough space for the hook, thingy. So, but what if I put like a 0 in here? No, it doesn't look like A. Doesn't look like A. So I need some inspiration. Minecraft font. So how does Minecraft font actually solve that problem? Okay, Minecraft 10, but I want to see... Alright, so they actually just use more pixels. 1, 2, 3, 4, 5. So they have... Okay, so that explains. So they use at least 5 rows. I can paint a Mona Lisa with 5 rows, okay? So that's cheating. But that's the cheating I'm gonna take. Alright. So, let me see. So this is gonna be 5 then. Just invent 3 by 3 letters. Yeah, maybe this is a thing. Isn't it a thing? Because it's not that hard, right? So it's basically you have 2 to the power of 3. Right, so that's how many you can only have, like, well, no, 8. So this is how many characters you can have, right? So why not? It's actually getting too cold. I'm sorry. It's a Siberia. All right. So and let me see. Interestingly enough, what they do is that they put zeros in here, right? So this is zeros, and then they put ones in here. Okay, so that's A. Does it look like A? I think it does look like A. And in terms of B, B should be pretty straightforward, right? So you put 0, you put 1, but maybe in B you can actually be like this, right? Nah, it doesn't really work that well. Maybe we should go ahead and add even more columns, because that would give us like more interesting stuff. Yeah, let's actually add another column. I think we deserve that. I think we do in fact deserve another column. Let me quickly do that. So this is gonna be something like that, and because of this we can do it like that. So this is A, and by the way, for the A we can actually put 0 in here, and for B, right, this becomes that. And the reason why I want to have a B, right? So we have like 2 of them. So this is gonna be 1. This is gonna be another one. That looks like shit. I really like that. Yeah. Why does it look like shit? I don't even know. So, maybe we're gonna do it like that. Okay, whatever. So let's just keep it like that and see how it goes. Because I want you to like make sort of like a bump and just like go like this, but doesn't really work that well. Anyway, so let's actually try to render everything, right? Let's try to render everything and let's take a look at the result. Okay, what do we have? Well, I probably have to actually use fech, be black, and let me take a look. So here's A. Here's let's take a look at B. They actually don't look that bad. Look at them. Look at them. I think they look good. It's a fine looking bee, exactly. It's a fine looking bee. So to make it a little bit more readable, like so I don't have to like zoom in every time, let's actually add support for the size. Right, so the way I want to do that, so test text. So I want to say, okay, render all of that with 4 times as big of a font, right? So 4 times as big of a font. And it will fail because we don't have support for that font. And what we have to do, we have to go ahead and just like do that. Alright, so this is a glyph, but here is an interesting thing. We also have to multiply it by the size of the glyph. Right, so maybe I should actually call this glyph size. Right, so this is gonna be glyph size. And this is a glyph size. There we go. Alrighty, so this is a glyph size. And I iterate through all of these things. And this is the pixel position, right? So this is a pixel position, but all of that has to be also multiplied by the glyph size. Yeah, I think it has to be multiplied by the glyph size within that thing. Yeah. Right, and when we're blending the color, we should not put any pixels here anymore. We have to fill an entire rectangle. That's what we're doing now. Olive.c, and okay, so we have to put OC in here. So this is a PX, PY, but now we have to use glyph size for the width and height, and then we have to also specify the color. That way we're sort of like stretching the all of the pixels, right? Each pixel now is a rectangle. All right, so let me recompile this entire thing, and let's open the output and look at that. I don't have to zoom in. I don't have to zoom in anymore, right? So it actually works for me automatically. Now, I can even say, okay, multiply the size of the font by 8. Right, so multiply it by 8. I'm gonna open it like that, and there we go, we only can see one letter B. Great. Absolutely beautiful. I love it. Absolutely love it. So maybe we should actually not do that. Test text, so let's actually use 4. Right. And all of that, by the way, computed from just a simple array, right? So we have a simple array like that, and all of that is computed from just that. It's pretty cool, I think. So let's implement the next character. Let's implement C. Alright, so how a C would look like? That's a good question. So I think this has to go like this. This has to be 0. 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 This has to be 1. This has to be 1. And I wonder if... Let me actually steal that shite. Yeah, so they actually sort of like do this kind of stuff where they just like make a hook out of C. Yeah. I think that's a nice looking C. Alright, so let me try to do this kind of stuff and output PNG. And here is C. We have C and then B. Okay. So what about D? D what? D is not... I'm sorry. I wonder if there is a way to, like, just revert the words. Is there a way to do that? To revert? Reverse region. I'm pretty sure it's gonna actually reverse it vertically but not horizontally. What the fuck was that? Okay. Reverse region. Yeah, so it's actually... It created P though. Yeah, it created P. So... we managed to create P, which is not that bad. Now, I wonder... Emacs reverse columns. Because I'm really curious, like, is there any way to do that? Reverse buffer order. Numbering the rows... because there's a way to reverse the lines, but no way to reverse the columns. Can you really do that? I don't know. Transpose region. Okay, transpose. Ooh, transpose lines. That's pretty interesting. Transpose regions. Okay, so let's actually try to play with all that. I'm gonna copy paste this thing in here. Transpose. Transpose lines. Not sure if it worked. Yeah, that was dumb. Transpose regions. Something went wrong. It didn't work. Alright, I think I have to do that manually. So you know how I'm gonna do that? You know how I'm gonna do that? I'm gonna literally do it like this. Right. So that's how I'm gonna do that. Maybe I'm gonna even copy paste this thing like so. Right. So this is D, which means, okay, so that makes it relatively easy, right? So it makes it relatively easy where I can just like do it like that. And this is D. Okay, there we go. So that was relatively easy. A, B, C, D, and let's try to just do that. Okay. That's pretty cool. So using the quick brown fox jumps over the lazy dog is actually super cool because it contains all of the characters. It just contains all of them, so it's pretty convenient, I think. I think it's pretty convenient. Olive.c, ABCD, E. How would you implement E, chat? How would you implement E? Can I quickly do query replace 1, 0, boom, and we zeroed everything out. So let me try to think, how would I creatively depict E? I would guess it would be something like this. Right. I would make a super wild guess. That it looks something like this. Does it look like E? I think it looks like E. That's a pretty cool E, not gonna lie. Right. So let's go ahead and try to do that. And open this thing. And yep, this E looks like shit. And you know why? Because I feel like this particular pixel has to be filled in. Right, like that one. I have a strange feeling that it has to be filled in. Though it kind of looks like Ukrainian. Yeah. Right, I think. I think this is probably how it looks like, maybe? Yeah. Yeah, it does look like it. Okay. So the thing I wanted to do is, I think it has to be... Yeah, it has to be like this, definitely. It definitely has to be like this. Okay. Yeah, now look at that. Look at that. That is cool, I think. Let's actually take a look at the Minecraft font and see how they did that. They also put that pixel in there. Yeah, they also did that because it does make sense. Okay, that's so cool. Okay, so with F, we have a little bit of a problem. So I feel like for this kind of fonts, they are using like 2 extra... Yeah, they're using 2 extra rows in here. Yeah, this is something that we'll have to do. Though, because of the extra rows, they also use extra columns. Yes. Okay. So let me see in terms of like F, what can we do in F in here? So this is F, and let's query replace 1 to 0. F. I would presume that F would look like this. Right, so this is F, and yep. 1 F. That's a pretty scuffed looking F, but maybe that's fine. Right, maybe that is totally fine. so let me take a look. It's not that bad. Look at it. Look at it. It's actually pretty cool. G. Let's do the G. So maybe I want to make a small break. Right, I want to make a small break and make a cup of tea, because I didn't make a cup of tea right before the stream. So I think the time has come to do it right now. So what's interesting is that we basically already developed the font rendering engine, so to speak. Right, so we can already kind of claim that this feature is done, right? We can claim that this feature is done and just move on to something else, and then I'm gonna add the rest of the glyphs as I need them already off screen, because you get the idea of how to create such fonts. And again, this entire definition is actually crafted so you can make your own fonts of any size, right? So, and furthermore, maybe you want to use TTF fonts, as already mentioned, right? So you want to use TTF fonts, you would make an atlas with a third-party library that loads up TTF font, makes an atlas, and you would just turn that atlas into this format, and this library is going to be using that, right? So it's pretty straightforward, I would say. Right, so I think it's pretty cool. It doesn't support like fancy positioning, like kerning or anything like that, but maybe it will in the future. Who knows? Maybe we're going to add that information in here. As it's needed, but I don't feel like it's needed, because like you want to render text usually for some like debug purposes. So yeah, let's make a small break. I'm gonna make a cup of tea and we're gonna continue working. All right, so let's go ahead and maybe try to use this text rendering tool in one of the examples just to see how it works. Right, let me go. So we have 3D example. Let's actually try to put something in that 3D example. Right, so let's go examples 3D. So there was a function called render, and here we render the scene, and after we render the scene, I think it makes sense to render some text, right, to just demonstrate that we're capable of rendering text as well. Olive.c text. There we go. So we're gonna provide OC, and the text is gonna be. Let's actually try to use some of the letters that we already have. Like we have A, B. Let's add O as well, right? And this is what I was talking about, right? So, for instance, I'm about to use a glyph that doesn't exist, right? I'm about to use a glyph that doesn't exist, but it's super easy for me to just add that single glyph. And I will do that every time I just try to render something and I don't have a glyph, I just add it, and eventually I will add all of the glyphs. And maybe that way I'll figure out the redundant letters of the Latin alphabet, and then I will use that knowledge to propose to remove them from the alphabet. Right. Remove letter H, I never used it, so yeah. Anyway, let me see. So how do you even draw the letter O? Let me think. I'm gonna. God damn it! So it was in an insertion mode. Boom. Right. So let's go back to insertion mode and let's just do it like so. Boom, 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 boom. I want you in my room. Why did I fucking say that? So we have O, so we should be able to render a boba. We're gonna render a boba maybe down there, right? So x is gonna be 0, but that also means that we have to take the height of this thing And I feel like we have to add some sort of a padding, right? So let's do a boba padding, right? And then here is going to be a boba padding, right? So then we're going to provide the default font, right? So here's the default font, just that. And the size is going to be around, let's say 16, why not? And the color is going to be white, right? It's going to be completely white. The padding, let's say that the padding is going to be around like 50, right? It's going to be around 50, and let me try to rebuild the entire thing. And something is completely wrong. I wonder what. So something like just failed miserably. And within the implementation as well. I'm not really sure. Comparison. Oh, this is because I'm compiling with the proper flags now. Okay, so that makes sense. So I know that this thing, py, has to be... well, it could be actually something else. So let me make this an int. I think that's fair. That is rather fair. So, and in here, string file not found. Are you freaking crazy, my dude? Oh, this is because I'm compiling shit without the... Okay. I'm compiling shit without the standard library for the WebAssembly. Right. So remember how I said that, like, we don't really want to depend too much on the standard library because you may be using that in an embedded. So, and in WebAssembly, you basically program an embedded, at least in the WebAssembly style that I use, right? So when I program in WebAssembly, I like to not like link with too many things. All right. So, but because of that, you won't be able to do just this thing, which is probably fine, if you know what I mean. Because we can always do the following stuff, right? So just and we also do text, right? While text is not equal to null terminator, right? And on top of that, when we increment we also increment text, right? So I think that makes sense. And interestingly enough, we can always just do text, but we can dereference the current letter in here. So something like this. And we do need in fact. We do need because we need to know the the index and stuff like that. So we do not refer to a text index anywhere, so that should be fine. So that way we don't need strlen, right? So we just don't need that anymore. And now I should be able to compile all of that. Okay, that's cool. And let's do bin 3D, and that looks very interesting. You can clearly see that we don't have any proper spaces. Okay, so I think we need to include the size of the font into the padding, right? So this is something that we don't really do, but I think it must be done, right? So the way we're gonna do that is we not only subtract the padding, we also subtract the default font height multiplied by the size, and we're gonna reuse this size like so. Size T, size 16. There we go. So that should work more or less correctly, and let's go ahead and do that, and boom. Yeah, there we go. So the problem with this font, as you can see, is that we don't have any spacing, like at all, completely. And maybe this is something that we have to fix. So the cool thing about this library is that we're literally rendering everything pixel by pixel without using any OpenGL. Well, I mean, technically we kind of use OpenGL because we're rendering pixel by pixel into the OpenGL texture eventually. But yeah, so this code may potentially work without like any anything special. So let's try to add a little bit of spacing between the characters, right? So how can we do that? We can do that by adding additional, additional columns, right? So let's quickly do that. I think that's the easiest way to do that. It's a little bit of a cheating, but I'm a cheater, forcing CD. Okay. Okay, there we go. So let's recompile. Would you look at that shit? Isn't that cool? Isn't that cool? Boba. Yes. And we can easily change all of that, I suppose. Right, so if I go to examples 3D, I can make it slightly smaller. Right, so let's actually make it twice as smaller and maybe say booba. I don't know. That's the meme word that everybody loves. Alright, so we have a text rendering. So, by the way, let's test this shit in WebAssembly. Right, let's test this shit in WebAssembly. Do we even compile that in WebAssembly? Yes, we do. Alright, so I'm gonna go to index.js and I'm gonna replace this thing with 3D and I'm gonna start my Python web server. Right, Python 3m HTTP server 69 as 69. There we go. So we already serving. And there we go, so we have a text rendering in the browser. So this entire thing, by the way, works regardless of the rendering target, right? So because it renders everything pixel by pixel. In fact, I'm pretty sure we can even port this entire stuff to ncurses. Yeah, this is actually very interesting because the library doesn't care where you output all of that stuff. It just doesn't care. So that means we can take the image and we just render it into ASCII. And it should technically work. That would be an interesting idea actually to implement at some point. So let's actually go back to a boba. Right. So maybe I'm going to actually put this thing in here. So the time has come, chat, for an epic commit. For an epic commit. Are you ready for an epic commit? I'm actually not sure if you are ready, my friends. I'm not sure if you're ready. Nobody's ready for this shit. Let me recompile everything one more time. I will probably have to add some tests, that's for sure. We need to add some tests. I'm gonna put it to do to add some tests. To do, add tests for text rendering, right? Alright. Implement, like initial implementation of the text rendering. There we go. I'm gonna push that right into the repo. Right into the repo.